Hey, we need to take a look at some special right triangles. So they are special. This first one is special because it's half of a square. If you take two corners of a square, two vertices of a square, and connect them together, you make a diagonal, and you have a special right triangle. So this relates closely to squares. It helps us with squares. Let's just see what, we could call it half a square. We could call it isosceles right. You remember a square has side lengths that are the same. So there's an isosceles and they have 90-degree angles. So it's an isosceles right triangle. And last but not least, we could also call it a blank blank 90 triangle. We're looking at the degrees of the angle measures. So what would the degrees of these two angles be? You might remember with an isosceles triangle, the base angles are also congruent. So take the remaining 90 degrees that you have out of the 180, divide by 2, you get a 45, 45, 90. So these are all names for this special kind of right triangle. Let's use the Pythagorean theorem and see what the internal ratios of this right triangle are. So I'm just gonna start with a very basic 45, 45, 90. We're gonna use 1 right there. And if this is 1, what's this got to be right here? Well, 1. And let's use the Pythagorean theorem to find this one right here. So 1 squared plus 1 squared equals something. We'll call it x right now, squared. So 1 squared is 1 plus 1, that's 2, equals x squared. Square root both sides, and x equals square root 2. How many square roots of 2 are we dealing with? Just one of them. So I'm just going to write a 1 square root of 2 there. Okay, so if you know that one side is 1, you know that the other leg has got to be 1, and then you just times 1 by the square root of 2 to get the hypotenuse. Let's do this. I hope I left myself enough room. I'm going to draw a considerably small 45, 45, 90. I'm going to draw a point right there. I'm going to do a little bit of a dilation here. So I'm going to go like that, like that, and like that. And then I'm going to double these lengths. So it's up here, like that, and like that. And then this one's got to be doubled like that. So we got this. Now this is taking me a little bit of time, but I think it's worth it. Okay, so in the first one right here we have 1, 1, square root 2. And in the second one we doubled it, so we're going to have 2 here. If we have 2 for this particular side length there, what's this side length here going to be? If you said 2, you're right. And notice we're doubling. We're going from 1 to 2. We're going from 1 to 2. So for the hypotenuse, we have to double the square root of 2. It's just 2 square roots of 2. And so that's it. Let's do a little bit of practice with this to make sure you're in good shape. I'm going to write my base one here. 1, 1, square root 2. Okay, now let's do this one. This is 3. It's a 45, 45, 90. So what's this length got to be right here? If you said 3, you're right. And what's this length got to be right here? Well, we're tripling how big these are. So we're just kind of tripling that square root of 2. We get 3 square roots of 2. Okay, here's an interesting one for you. This time we've got 4 square roots of 2 here. Okay. So the question is, how do I find the leg if I have the hypotenuse? And I know this is a 45, 45, 90. To get from here to there, we times by square root 2. How would you get from here to there? If you said divide by square root 2, let's think about it. Square root 2 divided by square root 2 gives you 1. It's kind of a reverse operation. So going this way, we're timesing by the square root of 2, and then coming backwards, we're dividing by the square root of 2. We get 1. So same idea with this this one down here. Going forwards, we times by the square root of 2. 3 to 3 squared is 2. And going backwards, we divide by the square root of 2. So 3 squared is 2 divided by square root of 2 just gives me 3. So what has this got to be right here? If we're going to divide by, what do we have to divide by here? The square root of 2, so it's 4 square root of 2 over square root of 2, and these cancel. Just get 4. And if that's 4, then this is 4 as well. Let's try one that's maybe a little tougher. What if I just had 5 right there? No square root 2, just 5. So this would have to be 5 divided by the square root of 2. And you might remember we have to rationalize the denominator, so you times the bottom and the top by square root of 2, you get 5 square root of 2 over 2. There you have it. Okay. What if this were another one? And this time we have square root, let's just go square root 8 just for fun. And to get from here to here, we divide by the square root of 2, so square root of 8 over square root 2. That's the same thing as square root 8 over 2, which is, that's just 4. What is the square root of 4? It's just 2. So here we have 2 right there. Interesting, square root of 8 is the same thing as 2 squared is 2. When you divide by the square root of 2, you can kind of see how that works. Anyway, I hope those examples help you a little bit. Thank you very much. This is the first in a series of 2 special kinds of right triangles. The first is a 45, 45, 90, and the second we'll talk about next time.